Hello, everyone. A very good evening and good morning. Thank you for joining us today in the BMCC webinar series on decommissioning. Today's topic will be wells, plugging and abandoning, installation removal, and subsea infrastructure removal. My name is Rohazwan. I'm the Public Affairs Manager in the British Malaysian Chamber of Commerce, or BMCC as we are more commonly known. BMCC is a bilateral trade organization well established for more than 57 years in Malaysia. Our key pillars as value propositions are networking and business-to-business engagements, branding and exposure, industry advocacy, especially through our sector committees, and last but not least, trade services. We are a member of the Britain in Southeast Asia and also part of the Global British Chamber of Commerce Network. BMCC is also the overseas delivery partner for the Department of International Trade in the UK, DIT. So this webinar series is an initiative by the BMCC Energy Committee as part of our networking and advocacy role in BMCC, in collaboration with the Scottish Development International, PETRONAS, and Decom North Sea as hosts for our Demio webinar platform. Joining us today is Mr. Hanif Hashim, the BMCC Board of Director and Chairman of the BMCC Energy Committee, Mr. Handan Ramli, the Senior General Manager, Production and Operations Management from PETRONAS, Ms. Jinda Nelson, Chairperson, Decom North Sea, and Mr. Jack Davidson, Managing Director from James Fisher Offshore, who will be our main speaker for today. For the Q&A session, we have Mr. Sridaran, Senior Energy Specialist in the Southeast Asia from the Scottish Development International as the moderator. And joining him and Mr. Jack later is Mr. Sven Salverson from ANT. So before we start our session, allow me to share some housekeeping. Number one, the webinar software Demio is fully encrypted and does not download onto your computer. Number two, please mute your microphone during the presentation by the speaker. Number three, use the public chat function at the right side of your screen to ask any questions during the presentation. We will attempt to answer your questions during the Q&A session if time permits. If you have any feedback with regards to the webinar platform, kindly send your feedback to events@decomnorthsea.com. Without further ado, I would like to welcome Mr. Hanif Hashim to do the opening remarks. Over to you, Hanif.
Can you guys see me and hear me loud and clear?
Yes.
I hope you can. Okay, so good evening to all and good morning to those in the UK. Welcome to the first ever virtual event organized by BMCC Energy Committee. We normally do something like this physically at hotels and whatnot, so this is the first ever. And in fact, to be honest with all of you, this is the first time I bump into the word Demio, which seems to be quite good, by the way. Saying good morning to the folks in the UK and saying good evening to those who's in my neck of the woods is probably one of the things that we need to get used to going forward because of COVID-19. So we should enjoy this new normal, and I hope this will be a successful event at the end of the day. Special thanks and welcome to our special guest today, as what the MC said just now, Mr. Handan Ramli. He's the SGM in PETRONAS. Literally, Encik Handan is the #1 guy looking after operations in our country. So thank you so much, Encik Handan, for being with us today. Ms. Jinda Nelson, Chairperson, Decom North Sea. I thought you were Malaysian just now when you said salam and selamat petang just now. I thought that's perfect, honestly. Davidson, Managing Director, James Fisher Offshore. And special thanks as well is given to our partners for today's session. PETRONAS is one, Scottish Development International, SDI is another, and Decom North Sea, last but not least. Now, very quickly, in addition to what the MC provided to you just now in terms of the overview or background of BMCC, allow me to give a bit more of background on BMCC. As what the MC said just now, it's a chamber that was introduced or came about more than 50 years ago or more than half a century ago. And since then, it has continuously served as a business community platform, linking investments between the two countries and linking businesses between the two countries and companies between the two countries as well. As of today, the Chamber has a support of over 300 local and foreign companies, and the members come from various industries. We are from oil and gas. There are also those who are from renewable energies or green energy, we call it. Definitely retail industry, and we are pretty big in the education sector because British is offering almost, very wide market share when it comes to education sector from the UK. So these are the type of companies or industries who represent or who are part of British Malaysia Chambers. And we will continue to advocate and support the mutual interests of both private sectors and the government sectors of both nations. And the very event that we are having right now, the event that all of us are attending right now, is one of the examples, classic example for which collaboration between private and national entities between the two countries are in effect. So that's what we do, exactly what we are doing right now. Now, there's one entity underneath BMCC, we call it Energy Committee. It was formed 3 years ago, July 17 of 2017. And the focus of this Energy Committee is primarily on Malaysia's energy industry, oil and gas and renewables. We were launched by the former British High Commissioner, Her Excellency Vicky Tredell, and it was attended by the number 2 of PETRONAS, or the top 3 in PETRONAS now. He is Mr. Adif Zulkifli, who is now the EVP of PETRONAS, and he attended the launching of the Energy Committee 3 years ago on behalf of the then PETRONAS CEO, Tan Sri Wanzo. Now, the role of this Energy Committee is to serve as the principal platform upon which partnerships and collaborations are formed between the UK and Malaysia oil and gas and energy companies and industries. We do have forums and dialogue sessions and networking sessions. The first forum was held in December of 2017, again 3 years ago, focusing on things that people talk a lot at the time, which was disruptive technology, innovation in oil and gas industry, machine learning, LNG. Those are the things that we started talking about 3 years ago. We then went on to host several other keynote addresses and networking events, promoting engagement and dialogues between companies and entities between the two countries. Amongst the key ones that we did the so-called Journey to Decom, that was done in collaboration with Malaysia's Oil and Gas Services Council, MOXI, and EIC. That was well attended. And we got regional participation from Brunei and Thailand at the time. I clearly remember that. We then, with the leadership of EIC, Energy Industries Council, 2 years ago, we call it EIC Connect Energy Malaysia. And I'm told by the High Commissioner at the time that that is an event which managed to attract the largest ever trade delegate from the UK into Malaysia. So that was a job well done, particularly by EIC, which is one of our members. We then had something called transitioning to renewables, because our industry should also be thinking forward, thinking about renewables. That was held 2 years ago, and we were pleasantly surprised by the attendance of the Minister of the Science of Technology at the time, which is Yeo Bee Yin. So she attended and gave a keynote address. So we were very blessed by her presence, by the way. And the last event that we did in this country, we call it BMCC Energy, Business Climate and Energy Outlook. That was done immediately, I think a few days before the movement control order by the government of Malaysia. That was sometime in March. And we are pleased to see that, the tickets were almost fully sold out. And the hotel that we booked was literally almost full house. So all these events have been successful, alhamdulillah, but they wouldn't have been possible and wouldn't have been successful without the collaborative efforts amongst our key supporters. Amongst, some of them are here today. PETRONAS is one, EIC is another, MOXI is another, and the British High Commission and SDI, definitely. Now, the theme for today's webinar cost competitiveness and optimization in driving decommissioning and abandonment in low oil price market. This is another ongoing effort to further promote key topics on Decom, a topic which we believe is an inevitable priority for Malaysia going forward. The Energy Committee believes that session like this one, a dialogue or engagement section like this, will benefit the local energy sector to connect and exchange ideas and opinions with the UK oil and gas experts in the field of Decom. Now, with the continued support from the Department of International Trade, DIT UK, Scottish Development International, SDI, and also others, we seek, or Energy Committee seeks, to foster closer collaboration with other organizations going forward. Now, we hope going forward we can host more beneficial engagement like this one, and obviously with your continuous support. Now, with this, I conclude my opening remarks. Once again, a note of appreciation to our special guest today, collaborators, speakers, and all of you who is making your time to attend this knowledge sharing session. So I wish everybody a successful event today. Thank you.
Thank you, Hanif. Now, I would like to welcome Mr. Handan Ramli from PETRONAS to give his special remarks. Mr. Handan.
Thank you, Mr. Rohazwan. Mr. Hanif Hashim, Chairman of the Energy Committee and Board Member of BMCC. Ms. Jinda Nelson, Chairperson of Decom North Sea, as the co-organizer together with Scottish Development International. Mr. Jack Davidson, Managing Director of James Fisher Offshore. Fellow colleague from PETRONAS, production arrangement contractors, service providers, and as well as a representative from Malaysia Learning Institution. So a very good evening to those in Malaysia. And for those in UK, a very good morning. So once again, thank you for your participation in this first webinar session of decommissioning and abandonment, an initiative by the BMCC Energy Committee, co-organized with PETRONAS, Scottish Development International, and Decom North Sea. So as we are in the new norm due to restriction caused by COVID-19, we are connecting through this virtual avenue. So notwithstanding, I believe this will not limit and hinder the cross-sharing to take place between UK and Malaysia. And this event was planned since 2019. So I'm pleased to see that we could gather almost all PSC representatives from Malaysia together with service providers and as well as academia here today. Of course, a big thank you to every one of you for making this happen. Malaysia oil and gas industry has clocked more than 100 years of existence. However, specific to decommissioning, we are still at an early stage and a lot more for us to learn. So for the past 18 years, we have begun various type of decommissioning project for petroleum facilities ranging from total offshore removal and onshore disposal. And we had performed rig to reef. In fact, we are good at this rig to reef program. We did remove least FPSO, FSO, well P&A, including the Subsea well, and also onshore plant decommissioning. And now we see the pace steadily growing moving forward. For every executed decommissioning project, valuable experiences are gained. This may be positive one, which we hope they mostly are, but also learning that need to be reflected and applied in the future for, among others, cost compression, but more importantly, to ensure safety and the preservation of the environment. Having said that, decommissioning offers significant opportunities for innovation, cost reduction, technology transfer, as well as development of regional skill and capability. I wish to share among our proudest achievement to date is the successful repurposing or relocating of wellhead platform to another field in Q4 late last year. By doing so, we have managed to extend the life of the facility as well as adding value to the recipient field. This innovative repurposed concept of wellhead platform decommissioning, relocation, modification, and commissioning marked the first of its kind in Malaysia and proudly achieved within time, schedule, as well as the scope. Of course, this experience coupled with number of rig-to-reef experience provide a glimpse of times ahead. So throughout the last 18 years of performing decommissioning in tandem with steers from strategic initiative, we have developed a 5-year decommissioning master plan. To date, PETRONAS is proud to be the pace setter in Southeast Asia region. Here, I wish to impress upon everyone in this session today that PETRONAS is indeed playing an active role within the region, collaborating among regulators and peers alike. The aim is to consolidate work plan across borders and championing a harmonized decommissioning regulation and sharing of best practices. For this, we are leveraging on the Asian Council on Petroleum, or in short, ASCOP. ASCOP Decommissioning Guideline, or ADG, was completed in 2015. The EDG is intended to be the regional decommissioning guideline tailored to the Southeast Asia region with full concurrent and mutual approval by the relevant national oil companies in accordance to international laws and regulation and complying with the national legislation of each member countries. Current efforts are to be further harmonize the ADG with the members countries' legislation. Admittedly, progress has been somewhat impacted over the last few months, but plans are already in place to resume discussion later this month. In our effort to revitalize Malaysia E&P industry, and despite often viewed as something negative, we have to acknowledge that decommissioning is coming. So based on PETRONAS activity outlook, PETRONAS is expecting a total of close to 100 wells to be plugged and abandonment between 2020 and 2022. Additionally, a total of 7 structure and 7 subsea facilities are to be decommissioned. This will require various types of services and resources. For example, in the case of lifting vessel, we are expecting the need to utilize a super heavy lift within next 3 years. This upfront view is key for all of us to prepare and, of course, be ready timely. So the challenges are significant, and it will be cost excessive and also spend several decades to fully execute. So it must be carried out safely and with care to protect the environment. So like it or not, the drastic shift in the industries with the current low oil price, depleting reserve, and operating cost challenges have made decommissioning inevitable. However, before embarking on decommissioning, there are other opportunities to maximize value. It is crucial to ensure that we have indeed maximized recovery and squeeze the last barrel from mature and late life asset. And this review and assessment need to be done for all upstream assets that we have. As you are aware, the cost and pace for decommissioning activities are being challenged by several uncertainties from a technical and technology standpoint, commercial, funding, as well as capability. With all these uncertainties, which will be part of the journey of decommissioning, some are within our control while others are beyond. The industry as a whole, including government as policy makers, operators, and service providers, shall continuously find best way to manage and contribute in our quest to ultimately bring down costs. So how can we do or deliver more with less during this low oil price environment? So there are 4 key considerations, namely technology, repurpose or reusability, cost, as well as the health, safety, and environment. Of course, meanwhile, the university and academia could help the industry by embarking on research and studies the result of which is hoped to lead toward cost compression and efficiency in decommissioning and abandonment execution. So taking this opportunity by encouraging cross-sharing among the various regions, it will be a chance for us, the Malaysian oil and gas industry, to listen, learn, expand our network and form collaboration. This is especially true on learning from past lessons as well as technologies that could improve abandonment and decommissioning execution, all in our pursuit of cost competitiveness and optimization in driving decommissioning and abandonment in the low oil price market. So in closing my speech, I wish to once again thank you for your participation and really look forward for the effective and fruitful session in this first decommissioning webinar. Thank you.
Thank you, Handan. Now, please welcome Ms. Jinda Nelson, Chairperson of Decom North Sea, for the second special remarks.
Ladies and gentlemen, with such a variation in geography and global timings here today, I'd like to say to our guests and colleagues in Malaysia, good evening, Sulimat Petang, and for those of us here in the UK and Europe, good morning. I'm absolutely delighted to see such an excellent turnout today. I understand that we have circa 160 people registered. So, on behalf of Decom North Sea, I warmly welcome you to the very first of this series of webinars that we're hosting on behalf of SDI. Some of you may be unfamiliar with Decom North Sea, so I'm just going to take a moment to introduce ourselves. Decom North Sea is a multi-region, not-for-profit membership organisation who are focused on late life and decommissioning, and we're headquartered here in Aberdeen. We've been around for 10 years and we're very excited to be working with SDI today. We have very close historic ties with Scottish Enterprise, which have led us to the honour of being invited to support Scottish Development International by acting as software hosts and facilitators to adopt improved communication and understanding between the UK and the Malaysian decommissioning markets. With the gracious support of PETRONAS and the British Malaysian Chamber of Commerce, we believe these events and the involvement of today's esteemed participants will only lead to the mutual benefit of all. Thank you for attending today, and I'll pass you over to the team.
Right, thank you, Ms. Jinda. So I welcome Mr. Jack Davidson as our main speaker. Allow me to share a bit of his profile. Jack is the Managing Director for James Fisher Offshore Limited, which is the parent company for James Fisher Marine Services in Berhad, James Fisher Offshore Incorporated, and their Middle East branch. He's responsible for all offshore subsea supporting businesses and the lead in driving the James Fisher and Sons PLC decommissioning strategy, with key markets for expansion being Asia Pacific, Americas, Middle East, and UK. His main responsibilities are developing local teams, regional operational capability, and sharing practices through live projects, endeavoring to share and build on lessons learned constantly. So please welcome Mr. Jack before we start our topic today. Mr. Jack.
Hi, good morning, everybody, and thanks for the introductions, and also thanks for the opportunity to come and talk to everybody. As everybody heard, I'm Jack Davidson. I'm the Managing Director for James Fisher Offshore. We are a global supporting business in support of the Tier 1 and local subsea contractors. We're a business that has touch points across the life of field of an oil field, including drilling, inspection, repair and maintenance, and then leading into decommissioning, and also we have a supporting arm into the renewables industry as well. I'm here today to talk about the advancement of abrasive water jet cutting in connection with decommissioning activities. And the reason that just to give a bit of background on myself, so surprisingly, when I look back, I have a career of 24 years, which makes me slightly older than I'd like to admit. My career started in the marine side of life, and then went into subsea and topsides work. The latter 12, 15 years of my career, it seen me involved in a lot of topsides and subsea maintenance and modifications, and also some decommissioning projects at study stage and at live execution stage. And a lot of that work seen me involved in the use of high pressure and ultra high pressure jetting equipment, which was used in surface preparation, pipeline descaling, general cleaning activities, and also abrasive water jet cutting. And through that, I've been fortunate enough to see the development and the advancement of that, of ultra high pressure and high pressure water jetting equipment, which leads me to the direction of travel that we took our business in. So having an involvement in decommissioning for going on for 10, 12 years, and then taking over as managing director of James Fisher Offshore, which, as I say, had a supporting arm in and around the subsea domain. Through that, we provided basic ROV and diver tooling solutions during inspection, repair and maintenance campaigns, but we also built up a substantial amount of knowledge of operating equipment on the back of a vessel and also subsea. So taking in the growing decommissioning market and the business's capability and my own desire to drive efficiencies in the decommissioning market is what set out a strategy around about 5 years ago for us to really drive the business towards being a operational supporting business to the international subsea community. And as many people have touched on there, decommissioning is a high cost activity, and it's an activity that when you go offshore to do it, it's not a dress rehearsal. And one of the key things, aside from the main health and safety and the environmental issues that have to be considered on every job all the time, one of the biggest considerations that we always take into account when we're looking at jobs, or when we're looking at new technology, or when we're looking at new regions of where we're going, is what activities we undertake have got an impact on vessel days and rig days. They are the highest cost element of any decommissioning activity. And when we're here to talk about the advancement of abrasive water jet cutting and associated technology, our effort is to maximise the technology that gives surety and certainty around abandonment and decommissioning activities, with an end goal to minimise the risk of project overrun where high-cost vessels or rigs are involved in the operation. Ultimately, we are one small piece of a very, very large project, but the activities that we're involved in have got a direct impact on the high-cost elements, being the heavy lift vessels or the abandonment rigs, or many other factors that come into it as well. So that's that background on myself and on the business is really where it's taken us today to develop and deliver a very rapidly growing decommissioning strategy. Just to give you an overview, live today, projects internationally, we're involved in a major decommissioning campaign in Thailand. We are 3/4 of the way through a significant platform and pipeline removal project in the Middle East that's been running for in excess of 13 months now. And we are live on well abandonment in the UK and have further well removal work in Malaysia as well. So, we have a business established in Malaysia. It's been established there for 6 years. We have a lot of local employees there, and we deliver from our office in Kuala Lumpur and our facility in Johor Bahru. We also have a growing presence in the Middle East, a very large footprint in the Gulf of Mexico with bases in Mexico as well, and obviously our home ground being the UK and Europe, where we're based in Aberdeen, and we service the UK market from there as well. We consider Fisher Offshore as a operational delivery business, and we understand the support and the requirements of our customers to deliver complex problems. We engage in new technology and new methods in support of those projects, and so as to be able to deliver the best decommissioning solutions. It's not always practical for us to go out and develop technology with a limited or blinkered skill set within the engineering of said technology. As I say, our main purpose is applying technology to complex problems. So when we established ourselves as a credible and capable player within the decommissioning market, our next step away from pipeline and infrastructure removal was moving into main structure removal, and now moving into well plug and abandonment. So in order for us to be able to develop that and deliver first-class service and right first-time service, we spent a long time looking around the market and evaluating different systems and different technologies that lent themselves towards abrasive water jet cutting. And over a number of years and working closely, we established a relationship with a very, very capable and high technology business in Germany called ANT, Applied New Technologies. And we purchased our first system from that business around about 2 years ago, 2.5 years ago. And the reason that I mention that is my colleague Sven Solverston from ANT is also on the call, and will be answering questions and answers at the end of the call. Is that one of the biggest things within decommissioning that is true across all projects is the only certainty is uncertainty, and no job is the same as the other job. And you know, many sayings could be thrown into that you know, no one solution fits every problem. So we considered how we were going to develop and what we were going to do, and we recognised that to be able to deliver the first-class service that we wanted to do, we had to establish a relationship with an engineering and technology business that is willing to take in lessons learned from every scope that we go and do, but also share best practice from other industries, so as we can develop technology and methods that minimise risk, that minimise the risk of project slippage and give certainty. So without labouring on too much about that and going into abrasive water jet cutting, I think that the first thing for me is, and it is my own belief, it's not anybody else's, but abrasive water jet cutting alone is not a technology. Abrasive water jet cutting is something that has been around for quite considerable time, both in industry but also naturally. You know, we have sand erosion on buildings around the world, we have sand erosion around in nature, and we have that, and all that is abrasives coming into contact with the surface. So effectively, abrasive water jet cutting is delivering a high velocity slurry to a point to be cut at. The technology comes around about how you control, how you deliver, and how you monitor that cut, particularly in the subsea environment, because the subsea environment, 8 times out of 10, you are cutting blind. You're either cutting in dark or murky waters, or you're cutting down a well, or you're obstructed by other structures. And it's very hard to visually assess how the cut progress is going and if the cut is complete. So the 3 main words, going back to that statement there, abrasive water jet cutting is not the technology that we're here to discuss or try and outline where the involvements or where the advancement of the technology has came. What we're going to try and cover is the delivery, the control, and how to monitor a cut. The other thing to touch on, and we can touch on it for hours and hours, and it's something that we must always consider, even in economic trying times, is the competency of the individuals offshore. Without the correct competency and skill set and knowledge, it is inevitable that a job will go wrong. And I think we can tie that back to the statement of decommissioning, you know, that the only certainty is uncertainty. So having a broad range of skills on board the vessel or on board the platform, not only who can operate the equipment, but actually understand what is required and what may happen when the operation is being undertaken. So I spend a lot of my time traveling around the different bases and different locations and talking to customers. And as I say, the biggest constituent part of our business and where we're heading as a larger business in the PLC side of things is decommissioning. So I spend a lot of time going around pitching for work or discussing problems within industry or other areas. When I mention abrasive water jet cutting, you usually get a gasp and a statement of, we've tried that before. And then you extend that and you ask the questions, okay, you've tried it before, but what are the issues? And a lot of the issues all stem back to similar problems. Nozzle blockages, incomplete cuts through stitches or spiral cuts, understanding of the progress or cut verification or cut monitoring rather than using the word verification, and also competence of the individuals carrying out the task. So ultimately, regardless of if it's a well severance or if it's a structural removal, the failure of any of those 4 points is going to guarantee project overrun. You're either going to have to recover the tool from the pile or the well, you're going to have to re-enter and make a new cut line at a new point, or you're going to suffer significant delays on the project. So what we do is we apply the technology to the delivery and the control and the monitoring of the abrasive water jet cutting, not the abrasive water jet cutting itself. So, as with anything, the second person along the line has always got the advantage of learning lessons from the first person, and also lessons learned from the industry, and that's why we're here today as well. That we want to share our lessons, and we want to share our development and our technology, and try and remove the underlying issues from past nozzle blockages or incomplete cuts or other areas. So, until the first step's taken, the second and third steps will never be taken, and you'll see on the left-hand side here of the screen a picture of the early 2000s, and then also a picture on the right-hand screen of one of the downhole cutting tools that we use. This is one of a range of 3 different sizes that we operate, but a fleet of 9 units that we are currently operating around the world. So fundamentally, both concepts are the same. It's a deployment tool with locking arms going down into a pile. However, you will see the technology on the right-hand side has got much more sophisticated locking mechanisms. You can see the cutting head at the base of it. So things have moved on. Capability has moved on. Understanding has moved on. And we've benefited from that. We've benefited from being able to apply the lessons learned. So first of all, I must apologise on this slide. That mechanical casing cutter statement should be on the right-hand element of the slide, not on the left-hand element of the side. So these pictures are generic pictures. They're not specific, they're not anything, but they're here to illustrate cuts gone not so well. We wouldn't say cuts gone wrong, because ultimately the item is on deck or in mid-flight. So the item on the left-hand side, the bit that's missing from that image is actually the internal pile, or the internal string. That is incomplete cut and had to be re-entered and severed. The picture in the middle is when any cutting method goes not so well, and ultimately explosives have to be used. The use of explosives in the marine environment is now a lot tighter controlled than it was many years ago. Even piling in renewables, wind farms, there has to be bubble curtains around to protect the marine life and the sustainability. So the use of explosives has its place, but it's not as much of a fallback method as it once was. The picture on the right-hand side is actually a cut that was started with abrasive water jet cutting but failed, and then a mechanical cut had to be entered into the well to actually complete the cut. So we're not really here to talk about mechanical cutting or anything else there, but these pictures illustrate some more of the problems that can be encountered on prior systems and prior technologies, and we're here to talk about how it's advanced. So these cuts are all cuts that have been completed in the last 18 months by ourselves. The cut on the left-hand side is a very recent trial cut for a job in Malaysia, which is mobilising in the next 10 days. That is probably one of the most complex subsea cuts that we could come across. That is a 36-inch conductor with 9 5/8 and 16-inch inner strings in a dual drilled well configuration. So not only is it a concentric cut, fully grouted, but it's to cut through 2 separate well strings. That is, I'm going to talk about that in a few other slides as well, but that cut was successful on single entry and single punch through and cut on a 360-degree rotation or 390-degree rotation. The upper picture in the centre of the slide is a slip-over jacket, 42-inch pile with a 36 inner pile fully grouted across. The lower section on that, and the reason it is very clear, that's a salvage job that we undertook last year in water depths of 190 metres. The steel thickness was 94 millimetres, and we achieved punch through in less than 20 seconds. The culmination of that is the nozzle standoff was actually 2 inches from the surface of the steel. So not only did we have the maximum water depth to contend with, but we also had the steel thickness with the standoff from the steel to contend with as well. Ultimately, that job was very successful, and we continued to cut at 190 metres for around about 14 days, removing significant sections of the hull to allow for the recovery of the material within it. The picture on the right-hand side is actually an external abrasive cut. This was a job in Malaysia. It was for a pile that had been installed incorrectly on a construction job earlier this year, and the removal method we put in was an external abrasive cut. So it was a 84-inch, 60 millimetre wall thickness pile, which we actually cut in around about 40 minutes or so, but we can touch on that later as well. So the abrasive method was chosen over and above diamond wire saw to mitigate against cumbersome frames, tidal and current issues of locating the frame in, and also snagging the diamond wire rope in there. So the points I mentioned earlier of the deliver, the control and the monitor, we've broken these down into challenges. And one of the biggest challenges we said is delivering abrasive slurry. As we're a supporting contractor to the subsea industry, you know, we have to, as everybody does, we have to tender competitively for every job that we do. And the unfortunate thing that we see time and time again now is that tenders are evaluated on a commercial basis as opposed to a technical basis. This we believe is wrong. The differentiator in the abrasive cutting technology is the build-up of the spread. You know, the spread of the equipment is critical to the safe delivery of the project. One of the most integral parts of any abrasive water jet cutting spread is the high pressure or ultra high pressure pump. The systems we use are all ultra high pressure. The areas that we operate in, Middle East, Asia Pacific, they all have high ambient climates. So the pumps that we use, they must have a full range of flow, but they also must be capable of running at long extended periods in high temperatures. As soon as that engine starts to lose performance, the pump will lose performance, and then therefore the velocity or the water jet is then deteriorated. Then you end up with nozzle integrity. Or nozzle integrity issues. The nozzle will degrade sooner, and you'll end up with an incomplete cut. The control and the dilution of garnet to water is absolutely imperative. You know, if you have no real control over the garnet quantities that you're delivering into the water stream, you are running a very, very high risk of garnet slugs, and also a reduced quantity of garnet into the water stream, which will mean that you will get no cut because you will purely be trying to cut with water. One of the key factors that is broadly overlooked and has a significant impact on the cut quality and the sustainability of the equipment is the electroconductivity of the water, which is used to cut. The other area which must be maintained and must be agreed during the engineering stage is the standoff distance from the surface. If we're too close to the surface, we will, and the material that we're removing will spring back towards the nozzle, and we will get nozzle degradation, and also we'll limit the velocity of the water jet that's coming out from there. So as we touched on there, you know, the key thing for us as a delivery business is within abrasive water jet cutting is maintaining the velocity of the water jet. If we can maintain velocity of the water jet at the point of cut, then we will have a successful cut. And in order to do that, we must maintain nozzle integrity and also our upstream equipment being the pump. So as we outlined, or as I outlined earlier, the cut that we showed on the high complex concentric cut for the dual well configuration, which is illustrated at the bottom of the screen in the pictures here. I took the opportunity to take the data from the nozzle and the running data from the pump. So the pumps that we use are high spec pumps, all zone rated, all suitable for running offshore. Our pumps have our engines have a maximum running speed or revs per minute of 2,100 revs per minute. We would never enter a cut, or we would never go offshore to do a cut when the engine was spec'd to be running at full RPM. So as we can see on the graph here, the orange line indicates the nozzle exit diameter. So the actual the diameter of the hole of the nozzle. So we start off with a 1 millimeter hole in our nozzle. The pump on this job started off at just above 1,350 RPM, and we were delivering 2,000, just shy of 2,200 bar at the nozzle. The cut, because it was on a trial basis, so we were only running one system. The extended period on the bottom that you will see there, it was a long cut, but because we were starting to refill the abrasive, the actual cut time was less than 300 minutes. But what you will see is that even during the full 360-degree cut, we actually had less than 5% nozzle degradation, which is quite significant. And the reason that we had that is we had high salt content in our water, and we also had high quality garnet. We were controlling the garnet at 10% by volume of water, and we had we maintained our standoff distance using our tools. So we maintained nozzle integrity. Now that nozzle degradation is imperative to understand, particularly when you're going down a complex well in there. If we encountered a problem downhole, or if we were encountering that we were not getting full punch through, knowing how long you've got left on that nozzle is imperative before you pull out to replace the nozzle or doing anything. And that is back to that first point that I mentioned, where you go in and speak to a customer and they say, we've used that before and we've had nozzle integrity issues, which has meant we've had to pull out of the well. So understanding that the degradation of the nozzle is directly related to how you control the garnet, how you control the water quality, and the upstream pump is imperative. So what I did, I took the same data, and as you'll see, the abrasive on time during that last slide, although it was an extended running period to complete the cut, the actual abrasive on time was only 312 minutes. So running the data up to the point of the full severance of that piece, and then running the same data up to where we would consider our nozzle still operating at 2,200 bar, delivering it's probably around about 28 litres a minute at the cut point. We could feasibly argue that we would still only be running at just over 1,700 RPM in our pump. That would still give us flexibility within that upstream equipment. Should we need to push that nozzle beyond optimum operating range, we can still do so. So delivering that optimum range is exactly what we aim for, although understanding that we can push that nozzle further and further on, it is imperative to delivering an offshore scope. As I said before, the key fundamentals that we always consider is vessel time and rig time. What can we do to minimize our customers' exposure on the rig time? This is stage one of what we can do. So you'll see there that taking that data on, we could have double the 3 times the cutting duration from what we actually completed on that cut. So the pump selection is imperative, and I can't emphasize this enough, that when a bid is evaluated, the technical spec of that equipment and what constitutes that equipment is imperative that it is considered along with, obviously, the day rate and the commercials. So thanks to my colleagues at ANT and various others, we've developed a lot, and these guys have developed a lot of understanding cross industry, cross nuclear, cross military, where the equipment is used in the mining, well, for the de-arming of mines and UXOs. Understanding one of the biggest degregators to the nozzle condition is actually the effect of the electroconductivity of the water. So as we'll see here, the orange span again is indicating the nozzle lifespan in hours on the right hand side of the graph, and then you have the electroconductivity of the actual water, of the water spec that is used during the cut. If we used fully deionized water, we could expect, and we have trialed this and demonstrated it, that we would have no longer lifespan in the nozzle than four hours. Using high salt content or salt water, we can extend that nozzle period up to in excess of 16 hours. So that broad operating window of the nozzle and the actual water quality that is delivered during the campaign is also imperative. One of the biggest things that we do at the start, during, and after each shift is we test the water, and we maintain and we manage our water quality throughout the duration of the job. So then we could still sticking with challenge. The first challenge is delivering the garnet to the cut point, I think well, if we consider the optimum garnet concentration is 10% by water volume, how do we manage that? I can touch on that on the next slide. But what this table shows here is a differential, and I think a lot of people consider things in a simple way of, we haven't got an effective cut, so we have to throw more. We have to throw more at it. So you throw more water, you throw more garnet at a lower pressure. But actually, the way to increase and optimize and improve on the cut quality is quite the opposite. We increase the pressure, we reduce the flow, and we reduce the garnet concentration, and we do that to maintain nozzle velocity. The reason that we keep on harping on about the velocity of the water jet is it's the energy that does the cut. It's not anything else. It's using the energy to perform the cut. If we can deliver the correct energy at the point of cut, we will get 100% severance. How we monitor and control that, we'll touch on that just to come on with. So if we take the example on the left-hand side of the table that's not got the box around about it, by increasing the volume of water and increasing the amount of garnet, we increase the kerf width, so we increase the quantity of material to be removed. We're making the cut more challenging for ourselves by doing that. If we reduce the volume of water, increase the pressure of delivery, we increase the velocity of the water jet, we decrease the quantity of garnet and control that garnet, we significantly reduce that kerf width to 50%. So we're making the cut easier for ourselves. We're not attempting to remove excessive material. We can then control that cut. The culmination of all of those factors, not forcing high volumes down the line, reducing the kerf width, we reduce the likelihood of nozzle blockage. Trying to remove too much material, having too much disturbance and force back at the nozzle is one of the primary reasons, along with the garnet concentration, of why you get nozzle blockages. Nozzle blockages are what cause the retraction of the tool from the hole, and you can never re-enter the same cut line twice. Once you've pulled out, you've got to go back in and do another 360-degree cut. How do we control the garnet? So we control the garnet at surface level. We operate a fully pressurized system. Our system is fully 2,500 bars. So upstream of this abrasive mixing unit is our pump unit, and then downstream is the overboarding equipment on the reeler and the tool. The pressure vessel that you see there is a pressure accumulator vessel operating at 2,500 bar, which we then charge up with abrasives. And we use high quality garnet during the operation. At the base of that vessel is part of our technology. It's part of the reason why we have success, is that we control the inducement of the garnet to the water stream. So we understand the volume of water, we understand the pressure that we're operating through our control system, which is then induces the correct quantity of garnet upstream and then maintains that garnet concentration in the water column to the point of delivery. So by doing that, we are not relying on fluidization and entrainment of a garnet through a Venturi effect. We are actually controlling and mixing the garnet at surface level for delivery subsea. This is a system that we use. We can use one pressure vessel, or we can use two pressure vessels combined to give continuous cutting. It just depends on the scope of work that we're going to do. So that's the first challenge, is delivering the slurry to the cut point, and also delivering the correct quantity of slurry to the cut point. And I keep coming back, and I'll keep saying this throughout this presentation. The key for us is maintaining nozzle velocity. That is what we strive to do, and that is what mitigates against industry issues in the past. The second bit is how do we control the cut? So what do we do, and how do we do this? We've undertaken quite a number of salvage jobs. We're obviously live on significant platform removal and well removal, and we've done some renewable structural removal. And controlling and maintaining that cut profile is difficult. There's no two ways about it. The fundamental basis that we do any internal cutting on is that our preference is to be mechanically locked in situ, and that's a key component of the equipment that we use and that has been manufactured, is that it has stepless hydraulic systems which extend out and exert 2 tons of force externally, locking in to the pile or the well to be cut. So we are static, we are at one with the structure to be cut. That gives us 100% stability in our cutting nozzle. That then, that gives us surety about, being able to rotate around the same cut line. Some systems, and all systems, have a place in the market. They rely on packers. They rely on inflatable packers to lock into the pile or the well. The packers rely on clean surfaces. And then they also allow for circular movement within the well or the pile, particularly if they're operated at high pressure. The centrifugal force from a high pressure pump is considerably greater than the centrifugal force from an ultra high pressure pump. So ultimately, you run the risk of getting spiral cuts as the head moves around. We lock in situ, and we are at one with the structure or the well to be cut. We do not remove from the structure until we've got 100% cut complete. Externally cutting, depending on the area of operation, there are a number of factors that must be considered. The effect of the tide, the effect of the current, the underlying current, ROV access. So when we design and we deploy bespoke external cutting systems, the key part for us is system rigidity. How straight can we keep that cut? And also, how do we manage the umbilical during that cut? Controlling the cut by way of connection to the work site is absolutely essential to be understood. Controlling and moving into it, and again, you hear about this nozzle velocity. So for many years, there was a underlying requirement to dewater a pile or a well that was to be cut. The fundamental reason to dewater that was to maintain nozzle velocity. So the drop off of the abrasive water jet slurry from the point of exit to the point of cut was significant, and it was more significant when you went across multi-strings or when you went across different areas of grouting or open air in between the multi-strings. We don't dewater, although we do at separate depths. So in a normal operation, sort of down to a maximum of around about 150, 160 meters, we don't have the requirement to dewater. And the reason that we don't do that is that we dewater the area around about the jet. So we don't use packers at normal operating depths for abrasive cutting. We do have packer systems for our equipment, and we use those packer systems in particular areas where we may suspect that there is going to be a differential of internal and external pressure. So we would use them when we want to maintain a positive internal pressure to prevent external pressure pushing in slurry, mud, or even fluids that might actually just reduce that nozzle velocity. So our primary basis of deployment is not to dewater the whole column or the whole jet or the whole well. We maintain our nozzle velocity by putting a high flow volume of air down our umbilical, exiting at the cut nozzle, which then creates a shroud around about the jet, as you'll see in the next slide, and it effectively localizes the dewatering and maintains 100% nozzle velocity throughout the progress of the jet. This dewatering and the air shroud actually continues through multi-string cutting. So even if we've got an integrity issue or there's a grouting issue in between multi-strings, we are still dewatering that area around about the jet, maintaining as high a nozzle velocity across the surface area as we possibly can. That's the technology that has allowed us to do what we consider as an industry first of that offset 36-inch dual well configuration, high nozzle velocity integrity. The third one is, controlling it is the 3S cut verification system or cut monitoring system, and I'll touch on what that is. But effectively, when you go in to do a well and a pile to a certain extent, you're going in blind. So how do you know you've got punch through? How do you know where you are in the cut? How do you know what your system's delivering? So ANT, our technology partner, have developed and continue to develop alongside us a cut verification system which works on multiple different sensors, and it indicates change. That's what it indicates. So it indicates change in circumstance within the pile or the well. That change then indicates to the operator the progress of the cut. And controlling the cut, obviously, customer engagement, understanding the quantifying the uncertainties of the cut. We predetermine our maximum cutting speeds. We predetermine our maximum nozzle force, and we predetermine our garnet usage prior to going offshore on any scopes. That then gives us a benchmark when we go offshore and a decided and agreed method statement to start the cut on. So just touch on each of these individually. So the controlling side of it and being locked integral to the pile or to the well, this is very important to us, and it's given us the confidence. It's given our customers the confidence. It's given industry the confidence that actually, abrasives can be used because you can maintain integral integrity of the cutting tool and the structure to be cut until you have 100% cut verification without recovering the tool. That gives us stability in our cut, it gives us stability in our verification system, and it gives us the ability to use our omnidirectional 360-degree cutting head to go back and then uncover any areas where there's any ambiguity about the cut. More so on the well severance side of things, as Sven, my colleague, might touch on later on, there was always a pre-requirement that scrapers had to be put down well. You had to have a clean surface. You have to have a debris-free surface in order to get the packers order to get the seal. We don't need that. Our stepless hydraulic systems are pressure sensitive, so they will always centralise inside the structure that they're inserted into. So being integral to the point of cut, both internal and external, is pivotal to controlling that cut. In this picture here, as I tried to probably quite complicated, explain the dewatering method, and this is proprietary technology to what we deliver, and it's absolutely imperative to maintaining and performing a cut, particularly in well abandonment, where we will be cutting across multi-string. We have a high likelihood of fluids or solids coming in from the externals. There is always uncertainty on the condition of the grouting. Is there grout there? Is there not grout there? It's actually easier for us to pass through a grouted area than it is a non-grouted area, because obviously you have a fluid ingress in the areas where there's any disparity on the grout. So as you'll see on the bottom picture, the graphic there, we induce the high volume of air down through the umbilical, and it exits through patented nozzles, which create a vortex around about the water jet. So that 1 millimeter nozzle is our main actuator for the cut. Shrouding that and dewatering localized throughout the cut progress gives us 100% nozzle velocity at the initial point of contact. We then maintain as high a velocity as possible throughout the cut. This is the integral and critical part of the operation. So by performing this localized dewatering, we're eliminating the need for packers, we're eliminating the need to scrape the surface, we're eliminating the risk of spiral cuts by being locked in situ, and we're delivering high velocity garnet at the surface. Maintaining nozzle standoff, as we touched on earlier on, high volume, high flow, high volume, low pressure, higher kerf, higher pressure, lower volume, lower kerf. Using the nozzle standoff is imperative to that. You're always going to have back pressure of material being removed. You're always going to have back pressure of the fluids coming back off the cut surface. As we enter a cut, the cut will always naturally offset from the 90-degree exit. It will always be cut backtracking towards towards the cut profile. Maintaining that nozzle standoff is imperative, and to do that, we have pressure-sensitive hydraulic systems on our systems. They can be preset for different diameters, but they don't need preset, and they have pressure wheels on the front of them that will detect any obstacles, and they will retract in to allow the nozzle to have a further standoff, but still maintain the cut on the rotation. Maintaining that nozzle standoff is absolutely critical for a successful cut. So then we move on to the third and the last challenge, and it's monitoring the cut. And this is a big subject that a lot of people have a lot of opinions on, and the more I think about it is externally it's relatively easy. We use some exceptionally high tech UHD 4K cameras that are available now, and we get feedback from them that you would never have expected to get from depths of 200 meters and more. We also have the use of ROVs, subsea on external cuts. So verifying an external cut is relatively simple, and the way that you do that is prior to you getting punched through, the blowback from the jet is astronomical. Once you get punched through, that almost dissipates completely, and you end up with a clear path, and you just see the air and the water exiting from the nozzle. Cutting internally in piles or in wells is different. Without any verification, you're effectively cutting blind. So how, you ask the question, how do you know you're cutting? You could answer, well, we're using more garnet, so we must be cutting. But where is the garnet going? There's all sorts of questions in the past that been struggled to answer. So monitoring that cut, we use a high-tech PLC multi-sensor system that gives us the ability to effectively monitor not only where we are in the cut, what our system is doing, and the progress towards the 360-degree verification. So it works on multiple sensors. It doesn't just take in one feed, it takes in 5 different feeds, and these vary from acceleration to hydrophones and various others. They then feed back into the main control system. And as I touched on before, what this monitors is change. So prior to doing any cutting, the system will be run through a dry test, and then it will be run through a test with abrasive on at low pressure. The system will then calibrate the internal reactions, whether that's through the acceleration or the acoustics or various other sensors that we have on there. That then sets a baseline and runs through the control system. The control system then also takes in the data from the ultra high pressure pump and the abrasive mixing unit. So the operator has complete control in one central location of the cut. And as I touched on, this system works on change. Change is the key. So when you get a change in noise, or you get a change in vibration, the system will indicate that. And through the pre-engineering and through the training and the competency of the individuals, the cut supervisor will understand what that change means. So when you punch through from one string to the next string, you will get change. So we can then optimize the cutting pressure. We can optimize the cutting speed. And you'll see along the top side of the screen image that you see there is a red line and then a green line. That red line is actually where the system was set up and there was no cutting being undertaken. And the green line shows that actually runs on the same traffic light system that you see down on the left-hand side of the screen. So should cuts be incomplete, or in fact significant variables come back in the data, this area will indicate orange and red lines, which then tells the operator, you may not have complete cut there, so you may want to go back to that stage. What we do is we don't necessarily stop straight away and rotate back round, because we're locked in situ within the well or the pile. We have the option to continue round or actually rotate back and do any areas of uncertainty. This control system is imperative when you are starting to talk about large structure removal, when you've got super heavy lift vessels sitting alongside a rig. All too often than not, the weight has been taken on the platform and the cut has not been complete. If that's the case, you have to re-enter every pile and complete another 360-degree cut. This system, when used and operated and delivered, gives further certainty as to the cut completeness. It also gives further certainty as to the pre-engineering and the delivery and how the system is performing on the job. Without this system, you can still operate. We train our guys in the operation of the system without the nice high-tech system, so that they understand what the mechanics of the system is actually also saying. It's understanding what this data is telling you and understanding what the system, what the actual upstream equipment is doing that cements that 100% cut completeness. So that's really the three fundamentals, delivering, controlling, and monitoring. And that's why we say that abrasive water jet cutting alone is not a technology. The technology is the component constituent parts that are added to it to maintain delivery, control, and the monitoring of the cut. So to give you some examples, this various images here is currently an ongoing live project. 25 jackets removed to date, and just under 3,000 kilometres of pipeline. Pipeline is cut with hydraulic cutting equipment and recovered with hydraulic grabs. All the slipover jackets are cut internally. They are all multi-string, ranging from 46-inch down to 20-inch. They do come with added complexity of significant grout overspill, which requires us to go down and use our internal high pressure jetting equipment to remove the grout before we go in with the tool.
and perform the cut. So to give you an example, the 46-inch piles with a 36-inch insert, average cut time being 46 minutes. And that not only is the cut time significant, but the fact that we on deck can say to the customer, yes, that's cut. We can move on to the next pile. That's time is money. Time and confidence is absolute key. Job in Malaysia, Boker, 84-inch, 60mm wall thickness jacket. On the top right-hand side of the screen, you'll see the very simple chain manipulator with the hydraulic tractor. So very easy diver deployment. We deployed that with we did the FAT in Johor with the divers from the vessel, because there was a week there was a week's mobilization time to the cut point, so we managed to have the divers out of SAT before they went offshore. And they came in and they actually did the dry runs with the chain assembly, and the whole assembly of the unit was taking them less than an hour, and it actually took them even less than that when they went offshore to do it. We had 100% contact with the surface at all times, or the steel surface at all times, and you'll see the cut quality that was on there, and we did that 84-inch in 35 minutes. So as opposed to using a diamond wire saw, absolutely no large frames or crane manoeuvring or current issues of putting the diamond wire saw in situ. Because it was a misaligned pile, had a diamond wire saw being used, you run the risk of actually the weight coming down the diamond wire rope and snagging the rope, at which point you're then stuck. You've got to retract the saw, you've got to recover the saw to deck and change the diamond wire saw. And you know, what I am saying here is that there is a place for everything. We own and operate a large fleet of diamond wire equipment. It's not always the most suitable, nor is abrasive water jet cutting. But when you see the cut time, the simplicity, the reduced HSE issues, but also going back to that key point, vessel time, certainty in the cut, certainty in the deployment, simple solutions using high-tech equipment guarantees the delivery. And apologies for the late images on this, but this is actually a live scope in the UK for well severance. And we've completed 3 of the 4, but to give you an illustration. And this is where, you know, this proves the statement of there is no more certainty than uncertainty in decommissioning. And we've gone into 6 different wells in the last 72 hours, and 3 of the wells, the plugs have been at inadequate depths or too high up, and the cuts have not been able to complete. We've drilled 1 conductor and the inner string is dropped, and then we've further gone into another 4 wells and completed the cuts. To give you an example of this one here, where the arrow is actually pointing to, that was a 30-inch conductor going down 20-inch, 13 3/8 and 10 3/4 inch. And we cut that in 220 minutes. We were using a single charge system on that job, so it was rotating at 120 degrees a minute, but we had to stop to refill the garment supply on the job. 100% cut complete, and client over the moon with the completeness of the cuts. So, you know, all that said, and you know where we're heading with abrasive water jet technology and the technology that surrounds the deployment of that is to aim for complete rigless P&A. You know, the advantages over mechanical cuts, the advantages over mechanical cutters, the advantages over historical systems, they're endless. But everything has its place in the market. But where the system that we now operate, and as we've proven across many jobs in the well severance and the structure removal side of it, we can eliminate the need to do a platform-based abandonment. We don't need mechanical cutting. We can cut complex wells in single entry. So we eliminate the need for the top drivers or rotary tables. So we're heading towards rigless. Concentric multi-string dual bore wells can be completed now in single entry.
Historically, you'd had to have done multiple entry with mechanical knives, so you'd had to do 9 5/8, withdraw out, do 16, then withdraw out, and then cut and you do. So you're in excess of 5-6 times the duration, and also quite time-consuming recovery and deployment, and then you have the historical problems with the knives, in that they can get stuck or they can break, or the grouting becomes an issue. Reducing the footprint and the weight. One of the significant aspects, particularly in Malaysia and other areas that we operate in, is when you're doing a platform-based recovery, some of these unmanned platforms or production jackets, they don't have the structural integrity to take large spreads of equipment. Our equipment is much reduced and substantially lower weight, so we can, if required, deploy onto smaller structures and use substantially less footprint. We are aiming for, and currently are, on multiple different locations, fully deploying from a vessel. The more that we go into this and being able to do platform wells from a vessel as well, that's where we are heading. The reduction of POB. We operate a business that has touch points across construction, back deck equipment, inspection, repair, and maintenance. We build our team up of competent personnel that can operate all of the equipment, but also maintain all of the equipment at all times. And being able to do that, and retaining staff and developing staff, particularly in local areas such as Malaysia, is critical to reducing the POB. Aside from vessel days, the second biggest cost is having people on a vessel. And can you afford to have people on a vessel that only have an hour or 2 hours work to do in between different jobs? So where we look to multidiscipline our personnel and integrate them into the vessel crew or the platform crew, we do that. And really the sum of all these parts gives us the ability, and gives PETRONAS and Subsea contractors the ability to look a little bit more robustly at cost models. Can they have certainty? A lot of decommissioning projects are bid on fixed price. What is the certainty around cut completeness? What is the certainty around severance times? What are the mitigating factors, and how do you reduce that risk of cost overrun? These are all the considerations that we take on board, and that we try and integrate into the development of our technology. So with that, and before I become very hoarse, I will hand it back, and I hope that has come across quite clearly and has been of benefit to all, and I thank you all for the opportunity to talk.
Thank you, Jack, for the insightful information of our topic today. Now we'll move to our Q&A session. As I mentioned earlier, if you have any questions, please use the chat function at the right side of your screen, and we'll attempt to answer your questions. Now, please welcome our moderator, Mr. Sridaran from SDI, Mr. Jack, and Mr. Sven. Over to you, Sri.
Hello. First part of the presentation. My name is Sri. I'm from Scottish Development International. We are working alongside the British Chamber here to put together the series of decommissioning webinar series that you're attending today, the first of the series. Without wasting too much time, we are behind schedule. So I would like to go through as many questions as I can. So if Jack and Sven are ready, I would just start showing some of the questions that I've got. You should be able to see them, but I will read them out loud if in case nobody can view them. So it's essentially 2 questions by Mr. Farhan from EnQuest. The first question is, can you advise if this operation will be done by divers or can be done by ROV? And the second part is, most of our platforms are having pile driven through the jacket leg. Can this abrasive water jet cutting cut through both the jacket leg and pile, or one at a time?
Yeah, I think I already. Hi, this is Sven Sobersen. I'm the abandonment advisor for A&T in Lübeck. I think I already answered that question. And number 1 is, of course, on the outside, cutting externally. We can use either ROV, that depends on the depth of the cut, or the diver. And internally, we don't need any because we are inserting the cutting manipulator at surface. When we are going to put wellheads, then we would typically use a diver to insert the cutting manipulator into the subsea wellhead. But I would first of all I would thank Jack for a superb presentation, and I would also like to come up with what Handan Ramli said in his opening speech, and he said that there was four issues: technology, usability, cost, and environment. And we have the whole industry have been screaming on rigless abandonments, and yes, this is what we are doing here is abandoning the wells rigless. We are removing the jacket or the drilling portion of the P&A part and doing it with abrasive and umbilicals. But now that we I believe that we fully control the abrasive cutting, where do we go now? Way forward. And again, we would like to do this rigless. So what we are doing now, we are developing tools. We are taking the abrasive downhole to replace section milling using a rig. Section milling that will remove not only the tubing and the casing, but also control lines and injection lines, so that you can set a T-plug. That means that you can do this from the same vessel as Jack mentioned. Also, as sidetracking using coiled tubing and our technology to make multi exits through the completion itself, so you don't need to put completion to make a sidetrack for multilateral wells. And you know, when you are going into these old wells, some of them have temporarily set bridge plugs, etc. That it's very, very hard to get rid of, especially with wireline, and you typically have to go and mill them out, and then you need a rig. We are in the process of developing tools that can wash through these obstructions, downhole obstruction, and then we are not talking about cutting, but we are talking about eroding, because when we are doing the cutting of piles, multi-string conductors, we are just opening up just enough for the jet to go through the multi-string, and the particles that comes out of the nozzle has a Mach 2, twice the sound speed. But downhole, we are more into the eroding part. We are not cutting. So
I think going back to the original question about the piles, as Sven touched on, yeah, I mean, the pile in pile is, and that's why I jumped back to that slide. And not to put it bluntly, but, you know, that's a relatively simple cut, to be honest. Where the issue is, and where we always need to consider, is the soil plug removal and the grouting. So the preparation ahead of cutting the jacket pile is absolutely imperative. You know, if you go down, more often than not on a slipover jacket, you've got grout overspill. And if you attempt to go down with grout overspill, and you'll block the nozzle rotation. So in an answer to your question, a jacket pile and pile slipover jacket, absolutely. And you know, we can go above and beyond the 76 inches with different extension arms on there. But the most important thing to consider during the engineering stage and the equipment you take offshore with you is the soil plug removal and how you can clean any grout overspill within the pile.
Thank you for that. I think we've got maybe one or two more questions that we can go through. Just looking at some of the options we have. And so the question is by Mr. Choi Yi Ho, who will, the question is, will you explain later how the water electroconductivity impact the cut? So I think I can pull it up.
Will you do that, Jack?
I can do it. What we can do is you'll get the contact details later, but and we can share some more of the study information on that. But effectively, the more conductivity that we can have through the water, we're displacing a high volume of water and garnet, creating a lot of energy within the water jet. So if we don't have the ability to have the conductivity through the water, then the effect on the tungsten nozzle is significant. So the more conductivity we can have within that water stream, the more that we can displace that electrical energy and have less effect on the nozzle. As I say, if you want more information on that, because it is quite a detailed study analysis, then we can certainly pick that up with you after this webinar.
Sure, and we will share the contact details as well, so our audience can get in touch with either us or the speakers directly. Just perhaps one other question. So this one is for Fisher Offshore here in Malaysia. The questions are very simple. How many teams and sets of equipment do you guys have here in Malaysia or in Southeast Asia?
Quite a lot, actually. It depends what we've got a very large facility in Johor Bahru. Currently, offshore technicians wise, I think we've got I think it's about 16, and then we've got the KL team, and we've got the administrative team in Kuala Lumpur. But operationally, abrasive spreads operating at the moment, we've got 2. Excuse me. And then we've got very large of subsea demolition equipment, which is the hydraulic shears and grabs and cutters and rotary gear. So yeah, we've got enough equipment there to fulfill. But obviously, the more work and the more deliverable that we can get there, we'll increase that. And we're hopeful that we can increase that technology. But I think, on your question, we are invested in Malaysia, and our main objective is the development of the Malaysian technicians and office staff. So we have Malaysian subsea engineers, and they're currently being brought into the James Fisher business. All of our Malaysian offshore technicians actually come back to the UK, and they undergo all their offshore vocational training for a period of 3 months over here, and then they continue on in their development, and they don't go offshore for a period of 3-4 months after that, until we've finished the competency. So we're investing significantly within the local content in Malaysia, and that's where we're going forward with things.
Okay. Unfortunately, we are out of time. I just want to thank to all of our speakers today. Thank you all for the questions. Unfortunately, I can't go through all of them, but we have taken note of all the questions that are in, and we will write to you directly. We have all the details. You will hear back either from our side or from the presenters directly. And I would like to pass it back to Ro for updating on some of our future initiatives that's coming up.
Right, thank you, Sri, Jack and Sven. On behalf of BMCC and the BMCC Energy Committee, we would like to thank our collaborators from the Scottish Development International, PETRONAS, and of course, Decom North Sea for hosting this webinar. Thank you to all our participants today. We hope you gain insightful knowledge and understanding of the topic. So we look forward to having you to joining our next session. Stay safe, everyone. Stay healthy as well.